In this problem, a student is planning on attending college. They need to take out a loan for $19,000 to pay for their tuition. The rate is 3.9%, and the length of the loan is 10 years, meaning they'll get 10 years to pay it off once the monthly payments start. But it's unsubsidized, meaning the interest that accrues while they're in school for those 4 years is not paid by the government, so they're on the hook for paying that. So we have to first calculate how much interest will accumulate in the 4 years that they're attending college. So we're going to use the simple interest formula right here and plug in all my information. So the principal is multiplied by the rate, always in a decimal form, times the term of the or the time, which is 4 years. That gives us $2,964 that accumulates while they're attending school for those 4 years. Now we have to figure out what the monthly payments will be. So the loan was originally $19,000, and we are going to take that and add all that interest that accumulates while they're in school, and that's going to be the new principal that is used in this formula. Besides the new principal that we're going to plug into the formula, I also have to plug in the rate in decimal form, as well as the n, which means, or which represents the number of payments that will happen. And because the loan needs to be paid in 10 years and there's 12 months in a year, we'll take 10 years times 12 months. And that'll give us 120 payments that need to be completed to pay off this loan. The first thing that you're going to want to do when you plug in this huge monthly payment formula is to add a fraction. And I could do that by using the key to the right of the 9, and I've got my fraction template right there. And then you could start entering all your information. So that's going to be 21,964. And then we hit multiplication with another fraction. And then we could type in our 0.039. Divided by 12. It'll always be 12 there. Then we arrow down to this bottom section. I got 1 minus, and then in parentheses, we're going to do 1 plus. I got to bring in another fraction. And then my rate again, 0.039. And then in the denominator, we put another 12. So this is 12 and this is 12. It always stays the same. And then you got to get outside of the parentheses, but you got to stay in the denominator, and then hit up this arrow, this up arrow key right here to get to the exponent. And then we're going to use a negative, and then this is going to be our the number of monthly payments. In this problem, there was 120 monthly payments. We press enter, and we've got our final answer here. This was $221.33 for the monthly payments. You'd always want to look to the right of the cents as well. So this is 33 cents. You see a 2 there. So let's keep that rounded at 33 cents. Now that we know that our monthly payments will be $221.33, we could figure out the total amount that she pays for this loan. So we take that monthly payment, and we're going to do that 120 times. When we multiply that together, that's going to give us our total installment, basically everything that gets put towards this loan. That's going to be $26,559.60, which is, of course, more than what the loan was originally costing her. The loan was about $19,000. So to figure out how much interest accumulated, or essentially the finance charge, we'll do some subtraction here. We'll take the total installment, everything that she paid in all those monthly payments for this loan, which was $26,559.60, and we'll subtract the loan cost, which was $19,000, and this gives us that extra amount of money that she had to pay in order to take out the loan, which was $7,559.60.